Finding the area between two curves. Let's look at an example. Find the area between the curves y equals 4x minus x squared plus 5 and y equals 5 minus x in the range x lies between 0 and 5. Now we can look at a couple of methods. In the first method, if we draw the graph, we can see the problem clearly. We want to find the area under the red graph, then subtract the area under the blue graph. Now, the red area is equal to the integral between 0 and 5 of 4x minus x squared plus 5 dx. Now, to integrate, 4x becomes 4x squared over 2, x squared becomes x cubed over 3, and 5 becomes 5x. And we're integrating still between 0 and 5. So we substitute in 5 into the equation, and then we subtract what we get when we substitute 0. So the area is 4 times 5 squared over 2 minus 5 cubed over 3 plus 5 times 5. Take away 0 minus 0 plus 0. So that's 50 minus 41 and 2/3 plus 25 minus 0, which gives us a red area of 33 1/3. Now the blue area is a triangle, so the area is a half the base times the height, which in this case is a half times 5 times 5, and so the area is a half of 25, which is 12 1/2. So the required area is 33 1/3 minus 12 1/2, which gives us an area of 20 5/6. Now, using a different method, we have the area that we want is the area under the red graph, which is the integral from 0 to 5 of 4x minus x squared plus 5 dx. Take away the area under the blue graph, which is the integral of 0 to 5 of 5 minus x dx. Now, since the limits are the same, we can combine the integrals. And this gives us the area of the first equation minus the second equation inside the integral sign. Now that simplifies to give the area is equal to the integral from 0 to 5 of 5x minus x squared dx. Now to integrate 5x we get 5x squared over 2, and to integrate x squared we get x cubed over 3. And those are between the limits 0 and 5. So we substitute 5 into the equation and then subtract, substituting 0 into the equation. So that gives us the area is 5 times 5 squared over 2 minus 5 cubed over 3, take away 0 minus 0. Well, that gives us 125 over 6, or 20 5/6, the same as before. Now this method is slightly shorter. Care is sometimes needed when finding the area between curves. For example, if we're asked to find the area between the graphs of y equals x cubed minus 5x squared plus 7x plus 1 and y equals x plus 1 in the range x lies between 0 and 3, we need to draw a diagram to see what's going on. Now, for the range x lies between 0 and 2, we want to find the area under the red graph minus the area under the blue graph. For the range x lies between 2 and 3, we want to find the area under the blue graph minus the area under the red graph. So, to work out area A, we work out the integral of x cubed minus 5x squared plus 7x plus 1, take away x plus 1 dx. Well, that simplifies to the integral of x cubed minus 5x squared plus 6x. And to integrate that, we have x cubed becomes x to the 4th over 4. 5x squared becomes 5x cubed over 3, and 6x becomes 6x squared over 2. And we substitute 2 into that and then take away what we get when we substitute 0 into that. So that gives us 2 to the power 4 over 4 minus 5 times 2 cubed over 3 plus 6 times 2 squared over 2, take away 0 minus 0 plus 0. Well, that simplifies to the area A equals 4 minus 13 1/3 plus 12, so area A is equal to 2 2/3. Now for area B, the red curve lies under the blue line. So that means we want to subtract the equation of the red curve away from the equation of the blue line. And so that is x plus 1 take away, in brackets, the equation of the red curve x cubed minus 5x squared plus 7x plus 1 dx. And that comes out to be the same as the original integration, except with a minus sign in front. So the area of B is equal to minus the integral between 2 and 3 of x cubed minus 5x squared plus 6x dx. And when we integrate that, we get the same result as before, but with minus in front. So minus x to the 4 over 4 minus 5x cubed over 3 plus 6x squared over 2. Now we substitute in 3, and then we take away what we get when we substitute in 2. So this time we've got minus, and then 3 to the power 4 over 4 minus 5 times 3 cubed over 3 plus 6 times 3 squared over 2. And then take away minus, or plus, 2 to the power 4 over 4 minus 5 times 2 cubed over 3 plus 6 times 2 squared over 2, which simplifies to minus, in brackets, 20 1/4 minus 45 plus 27, plus, in brackets, 4 minus 13 1/3 plus 12, which works out to be minus 2 1/4 plus 2 2/3, which is 2/3 minus 1/4, or 8 over 12 minus 3 over 12, so the area of B is 5 over 12. So the total area is 2 2/3 plus 5 over 12, or 2 and 8 over 12 plus 5 over 12, and so the total area is 3 1/12. The following is an exercise. You can pause the video at this point and have a go at it yourself. When you've tried the questions, you can restart the video and I'll go through the answers. Okay, let's go through the questions. In the first part of question 1, we're asked to find the intersection of the two graphs y equals x minus 2 all squared and y equals x. Well, to solve this, we need to eliminate y. Now, y is equal to x minus 2 all squared and y is equal to x. So if we eliminate y, we have x minus 2 squared is equal to x. So x squared minus 4x plus 4 is equal to x, or x squared minus 5x plus 4 is equal to 0. Now we can factorize that. We want two numbers that add to make minus 5 and multiply to make 4. So those numbers are minus 1 and minus 4. So it factorizes to x minus 1 into x minus 4 equals 0. And when two numbers multiply to make 0, one of them must be 0. So x minus 1 is 0, or x minus 4 is 0. So x is equal to 1, or x equals 4. Now we know y is equal to x, so that tells us the points of intersection are 1, 1 and 4, 4. Now in part 2, we're asked to draw the graph of the two equations. Well, let's plot the points for y equals x minus 2 all squared and draw the graph. Now we can make up a table with the following rows: x, x minus 2, and y, which is equal to x minus 2 squared. So let's choose values of x going from 0 to 4. Then x minus 2 is minus 2, minus 1, 0, 1 and 2. And so y, which is x minus 2 all squared, is minus 2 squared, which is 4, minus 1 squared, which is 1, 0 squared, which is 0, 1 squared, which is 1, and 2 squared, which is 4. Now we can plot those points and join them with a curve. We can also draw the graph of y equals x. This is just a straight line going up at 45 degrees from the origin O. We already know that it goes through the points 1, 1 and 4, 4. Now in part 3 we're asked to find the area between the graphs in the region between their intersections. Now we want to find the area between the graphs, and so that's the area below the blue line and above the red line for values of x between 1 and 4. So the area is the integral from 1 to 4 of x minus 2 all squared dx, which is the integral of x minus x squared minus 4x plus 4 dx, which is equal to the integral between 1 and 4 of minus x squared plus 5x minus 4 dx. Now when we integrate that, minus x squared becomes minus x cubed over 3. Plus 5x becomes plus 5x squared over 2, and minus 4 becomes minus 4x. So we substitute in 4, and then we take away what we get when we substitute in 1. So that gives us minus 4 cubed over 3, plus 5 times 4 squared over 2, minus 4 times 4. Take away, in brackets, minus 1 cubed over 3, plus 5 times 1 squared over 2, minus 4 times 1, which is minus 21 and a third plus 44 minus 16. Take away, in brackets, minus a third plus 2 1/2 minus 4, which is equal to 6 2/3 minus 2 1/6, which is equal to 4 1/2. So the required area is 4 1/2 units. In question 2, part 1, we're asked to find the intersections P and Q of the two graphs y equals x squared minus 2x plus 5 and y equals 2x squared plus 2. Now to do this, we need to eliminate y in the two equations. Now since both expressions in x are equal to y, we can put the two expressions equal to each other. So 2x squared plus 2 is equal to x squared minus 2x plus 5. So that simplifies to x squared plus 2x minus 3 equals 0. And we can factorise that. We want two numbers that add to make 2 and multiply to make minus 3. And they are plus 3 and minus 1. So the factors are x plus 3 into x minus 1, which is equal to 0. Now since they multiply to make 0, one of them must be 0. So x plus 3 is 0, or x minus 1 is 0. That means x is equal to minus 3, or x equals 1. Now if x is equal to minus 3, then y is equal to 2 times minus 3 squared plus 2, which works out to be 20. If x is 1, then y is 2 times 1 squared plus 2, which is equal to 4. So the points are P is minus 3, 20, and Q is 1, 4. Now in part 2, we're asked to sketch the two graphs. Well, probably the easiest way to do it is to plot 3 points. We know they both pass through the points minus 3, 20 and 1, 4. So we can plot the points between those. If we take the equation y equals x squared minus 2x plus 5, we can draw a table with x taking the values minus 2, minus 1 and 0. In the equation y equals x squared minus 2x plus 5, if x is equal to minus 2, we have y equals minus 2 squared minus 2 times minus 2 plus 5, which works out to be 13. If we take x is equal to minus 1, we have y equals minus 1 squared minus 2 times minus 1 plus 5, which works out to be 8. And if we take x as 0, then y is equal to 0 squared minus 2 times 0 plus 5, which equals 5. Now we can plot those points and join them with a smooth curve. Now if we look at the equation y equals 2x squared plus 2, we can again draw out a table with x taking the values minus 2, minus 1 and 0. So if y equals 2x squared plus 2, and if x is minus 2, then y is equal to 2 times minus 2 squared plus 2, which is equal to 10. If x is equal to minus 1, then y equals 2 times minus 1 squared plus 2, which is equal to 4. And if x is 0, then y equals 2 times 0 squared plus 2, which is 2. We can fill these in the table. Then we can plot the points and join with a smooth curve. Now in part 3 we're asked to find the area enclosed by the two graphs between P and Q. This is the pink area. Now the required area is the area under the red graph minus the area under the blue graph. So it's the integral between minus 3 and 1 of x squared minus 2x plus 5 take away 2x squared plus 2 dx. And that simplifies to the integral between minus 3 and 1 of minus x squared minus 2x plus 3 dx. And when we integrate minus x squared, it becomes minus x cubed over 3. When we integrate minus 2x, it becomes minus 2x squared over 2. And when we integrate 3, we get 3x, which simplifies to minus a third x cubed minus x squared plus 3x. We then substitute in x as 1 into the equation and take away substituting minus 3 into the equation. So that gives us minus a third times 1 cubed minus 1 squared plus 3 times 1. Take away minus a third times minus 3 cubed minus 3 times minus 3 squared plus 3 times minus 3. Now that's equal to minus a third minus 1 plus 3, take away in brackets 9 take away 9 take away 9, which gives you 1 and 2/3 take away minus 9 or plus 9, and so that gives you a total area of 10 and 2/3. Now in question 3, the diagram opposite shows two graphs. Y equals x cubed minus 5x squared plus 3x plus 8, and y equals x, and we're asked to find the shaded region. Now, if we look at the diagram, we see that for the region x lies between minus 1 and 2, the graph of the cubic equation is higher. So that means the area A is equal to the integral between 2 and minus 1 of x cubed minus 5x squared plus 3x plus 8, take away x. Now that's equal to the integral from minus 1 to 2 of x cubed minus 5x squared plus 2x plus 8. Now when we integrate that, x cubed becomes x to the 4th over 4, 5x squared becomes 5x cubed over 3, 2x becomes 2x squared over 2, and 8 becomes 8x. And we substitute 2 and minus 1 into that. So that gives you 2 to the power 4 over 4, minus 5 times 2 cubed over 3, plus 2 times 2 squared over 2, plus 8 times 2, take away minus 1 to the 4 over 4, minus 5 times minus 1 cubed over 3, plus 2 times minus 1 squared over 2, plus 8 times minus 1. So the area comes to be 4 minus 13 1/3 plus 4 plus 16, take away in brackets 1/4 plus 1 2/3 plus 1 minus 8. which is 10 and 2/3 take away minus 5 and a 12th. So area A is equal to 15 and 3/4. Now for area B, we're going to take away the area of the cubic from the area of the line. So area B is the integral from 2 to 4 of x take away in brackets x cubed minus 5x squared plus 3x plus 8 dx, or minus x cubed plus 5x squared minus 2x minus 8 dx. Well, when we integrate minus x cubed, we get minus x to the 4 over 4. When we integrate 5x squared, we get 5x cubed over 3. And when we integrate 2x, we get 2x squared over 2. When we integrate minus 8, we get minus 8x. Now we substitute in the values 4 and 2, and so this gives us minus 4 to the power 4 over 4, plus 5 times 4 cubed over 3, minus 2 times 4 squared over 2, minus 8 times 4. And we take away minus 2 to the power 4 over 4, plus 5 times 2 cubed over 3, minus 2 times 2 squared over 2, minus 8 times 2. So all of that simplifies to, in brackets, minus 64 plus 106 and 2/3, minus 16 minus 32, and then in brackets take away minus 4 plus 13 and a third, minus 4 minus 16, which gives us minus 5 and a third take away minus 10 and 2/3. So the area of B is 5 and 1/3. So that means the total area is 15 and 3/4 plus 5 and 1/3, which is equal to 21 and 1/6.